Antarctica career trial with Neil, Daniela, Natasha, and Paul.
Transverse waves are lightweight. They move up and down. Longitudinal or compression waves or sound waves. They are emitted into one direction, but when bounced off, they move into different directions or various directions, as you may. Labels of compression waves. Refraction is when it's spread out. Compression is spread in. Direction of energy is into one. And wavelength is the length of a wave. Energy source is various. Labels of transverse waves. Wavelength is the length of a wave. Breadth is when waves are high. Strokes are when waves are low. Zero displacement line is when it's zero, when it starts. And amplitude is where its maximum displacement rate. Light bulbs in Antarctica. In Antarctica, LED flashlights are better than traditional light. Reason being is because they save 30% more energy and produce more light. As seen in this picture, they only use 3 watts to 9 watts compared to 60 watts.
The particle model is sound and it travels through a medium. It also travels in waves, and the more denser the matter, the more vibrations can occur, and then vibrations can affect the particles that are nearby. Sound travels fastest in the denser material. Gas is slowest as it goes approximately 1 kilometer per second. Liquid is medium, whereas solid is the fastest. Using sonar technology from on-board ships, scientists from British Antarctic Survey and other scientific organisations captured the most substantial ongoing set images of the seafloor around the Amundsen Sea. This territory is a vital point of the West Antarctic ice sheet and considered by some scientists to be the most likely place for the reason of major ice sheet collapse.
Electromagnetic spectrum. As we can see in the EMS, radio waves are the longest and gamma rays are the shortest. The longer the wave, the less frequent the particles move, while the shorter wave, the more frequent the particles move. In physics, we know the sun's radiation is infrared and ultraviolet radiation. The UV rays are more intense than the infrared radiation because they are shorter in length, meaning the particles are freely moving due to the intense heat.
Absorption. Absorption is how light is absorbed in a mirror or within any object or surface. The energy is usually transformed into heat energy, therefore the light is absorbed. See, what we have here is a lighter. We know that fire is light. See, it's absorbing the light. As you can see, it's absorbing it, which is actually heat. It's actually melting the water because it was in the fridge. You see it. Anyways, there, it's done. Move on. Reflection. Reflection is when light is bounced off or struck off against any object or any surface. Like light. It's struck off, see? This is like a convex mirror because it's going outwards. It's like that, yeah? It's going this way. Instead of a flat mirror, we use a watch. It may not be flat, but it may not be flat as a flat mirror, but we can see that it still reflects. See that? Yeah, see? It works.
Refraction is when light is bounced off a surface or object, like this chopstick in a glass of water. As you can see, it's the light is bending the chopstick, making it bigger in the water, but really it's actually thinner. It's bending the light off the water. We know that in some situations you may be stuck under mountains of ice or snow, or if you're in a submarine and you want to see what's in front of you. You know that ice or snow absorbs light as the color of snow is white, but ice varies in reflection and absorption as it is transsucculent, hence it is half opaque and half transparent. Same as water, as it reflects off the surface, but underwater there is light that penetrates through the surface of water as well. For instance, an ice glacier absorbs light as it naturally absorbs sunlight and it reflects this light due to the fact that solar radiation is ultraviolet rays. This is one of the reasons why the ice is blue, as it is close to ultraviolet wave in the visible light rather than infrared wave.
How to build a periscope?
To construct a periscope, you must gather all following material: 1. A3 paper, scissors, sticky tape, 2 flat mirrors, a pencil or a pen. 2. Place the 2 flat mirrors on the ends of the A3 paper and fold the A3 paper until a rectangular prism is found, form. 3. Draw a rectangle on the ends of the A3 paper and then cut so you can see inside. 4. When that is done, place the 2 flat mirrors inside at the end at a 45-degree angle so you can see the other mirror. Then you're done.
Voltage is the amount of electrical charges within an object, which is titled volt for plural. Current is a flow of electricity from a specific direction. Resistance is an extent where an object rejects an electric surge. This is called dissipation. Series circuits Series circuits. The current is equal in all resistors, which is the same to the battery. The total voltage decreases from separate resistors in the same voltage rating as the battery. All of the resistance of the group of resistors is the same total value of the separate resistance values. Parallel circuits. The flow of voltage is the same on every parallel branch. The total current in each separate branch is the same the current outside of them. The equivalent or total resistance of the group of resistors is given by the equation.
Okay. Series circuits in Antarctica is more applicable on handheld electronic devices, or other words, portable electronics with a rechargeable battery. It's more useful for field operations other than uses in the base camp. For instance, if a person was lost, just an example of a scenario, a team could use only one flashlight and it ran out of batteries. Another member of the group can take one out without any trouble. This way, if a person brought a flashlight with a parallel circuit, it would require more energy and mass for the process of converting electricity to light or sound. It's really applicable if there was a blackout in the base camp and none of the light bulbs will switch. A flashlight is the main tool in order to see in the dark. Also, another alternative of a scenario where a flashlight dies, you can easily replace it with spare batteries in your pocket or bag.
Parallel circuits in Antarctica is applied within the whole base camp, just like most ordinary households. The main feature about parallel circuits is that if one light bulb explodes, only that light bulb is affected, instead of turning off all connected electrical appliances due to the various passages in parallel circuits. However, a disadvantage to parallel circuits, especially in Antarctica, is that if there was a blackout, which may last a few seconds or minutes, but weeks in extreme cases, due to insufficient electricity or faulty power lines or wires, aside from backup generators. Despite that, in greener or eco-friendly ways, they may use solar power as a source of energy, which is efficient depending on what type of solar panels. It could be the old version of solar panels, where it absorbs solar energy when the sun's out and converted into electricity, but when it comes to night time, it's completely useless. Which is bad, since 8 months of Antarctica is winter or complete darkness. On the other hand, the conventional version doesn't just absorb solar energy, converting it directly to the generators. Instead, it has an extra feature of storing solar energy that used to be used for later uses, when people or electrical devices aren't being operated.
Recommendations of light bulbs. Traditional incandescent light bulbs equals 1600 lumens. Halogen incandescent equals 77 watts per 1600 lumens. Compact fluorescent equals 23 watts per 1600 lumens. Light emitting diode equals 20 watts per 1600 lumens. Brightness efficiency 1. LED saves 80% more than traditional incandescent light bulbs, making it the most efficient of them all. 2. CFL equals 77% more than traditional incandescent light bulbs, but wastes watts than LED though. 3. Halogen equals 23%, slightly saves more than traditional incandescent light bulbs, but not as good as the previous 2. 4. Traditional incandescent saves 0%, making the least effective. Lifespan, LED equals 20,000 hours more durable, 26.67% more than traditional incandescent. CFL equals 10,000 hours more durable, 13.33%. Halogen equals 1,000 hours less durable, 1.3%. Traditional incandescent equals 750 hours less durable, 0%. 750 hours equals nearly 4.5 weeks or 31.25 days, about a month changing. 1,000 hours equals nearly 6 weeks or 41.67 days, about a month and nearly a half. 10,000 hours equals nearly 60 weeks or 416.67 days or a year and a fifth. 20,000 hours equals about 119 weeks or 833.33 days or more than 2 years and a quarter.
Therefore, LED light bulbs are the most
conventional, as it is 80% more efficient in brightness and 26.67% more durable than traditional incandescent light
Total
bulbs.
wattage of all electrical appliances adds up to 122,795 watts, but only 20,465 and 83 watts is used in one day. In winter, which is 8 months in Antarctica, we use 4,911,799 watts, while in summer it's 2 months using 40,929 watts in total. Within a whole year, 4,952,728 watts is used, or about 5 million watts or 5,000 kilowatts a year is used. This is what we've modified and came up with. LED light bulbs board in every room, solar panels on each rooftop, concentrated with refracting mirrors to capture sunlight, carpet flooring on the sleeping and command module for insulation and warmth, tiles covered with rubber mats on the kitchen in order for grip and less chance of slipping or various stains on people's legs on cold surfaces, hardwood or timber flooring on the dining area, including the rest of the recreation module for durable performance if a heavy object was to fall and damage the floor, or simply just a strong and durable wood, sound and shockproof windows for resistance of intense winds and extreme temperatures, hydroelectric backup generators used with a blackout occurs. Simply add water and we are back on track. Approved OH&S or occupational health and safety requirements, like first aid kits on every module for chemical, radioactive, toxicological contamination, or simple physical damage. Diagrams of safety procedures on most walls on every module for safety reasons.
Strong arguments how this is relevant to staff in the Antarctic basin. The reasons why all of this information is relevant to the staff in the Antarctic base station is because of the thorough explanation of the electromagnetic spectrum. Plus, we evaluated and gave examples of how the waves and rays were used in order to communicate with people across the whole planet via satellite. We know how light travels, reacts to objects or surfaces. Light is absorbed, reflected, so on. Like how we can harness some of these ideas and turn it into real-life situations, like creating a periscope. If you go underneath a glacier and you can't reach the top of the glacier and you want to see what's happening above, but you can't unless you have a periscope, which can help you view your wanted scenery that you were looking for. In addition, we are all experienced with electricity, especially with light bulbs or globe with their lumens, watts, and also the conservation of electric currents by using more reliable electrical appliances or devices. In Antarctica, the following branches or fields of science have developed:
cartography, topography, geology, ecology, meteorology, microbiology, biology, physics, astronomy, chemistry, paleontology, botany, zoology, statistics, and mathematics.